In this question, we're asking which of the following reactions is not considered to be an Ohm-Coulomb reaction. What an Ohm-Coulomb reaction is when you're adding something that adds a nucleophile that normally would be an electrophile, or something adding normally that would be an electrophile. Normally that would be a nucleophile and adding it as an electrophile. What Ohm-Coulomb means is that it's German for reverse polarity. In the context of reactions that we've been talking about adding carbonyls species as nucleophiles, as opposed to carbonyls typically acting as electrophiles. So if we take a look at this reaction right here, this reaction is a benzoin condensation. Essentially what we end up having is two aldehydes coming together. And to get this product right here, one of those aldehydes has to exist as a nucleophile. So this is an Ohm-Coulomb reaction. It's called the benzoin condensation. B, if we take a look at B, in order for this to work, we would have to change our aldehyde into this nucleophile to add in a Michael fashion to the Michael acceptor to give the 1,4-dicarbonyl. This is an Ohm-Coulomb reaction called a Stetter reaction. Now if we take a look at, so it comes down to C and D. Take a look at C, the reaction is KCN and Cn minus, adding this, electrons go on, and we get a nitrile. And then we add acid and water to that nitrile, and get a carboxylic acid. D, what we're doing is we're changing the bromide to a Grignard reagent, and then that Grignard reagent is reacting with carbon dioxide. Give the carboxylate, which then is protonated to give the carboxylic acid. So one of these two. Well, if we take a look, the carbonyl carbon, this carbon right here, here's this carbon, which is this carbon, or so. And if you notice over here, this carbon is a nucleophile. If we take a look over here, this carbon is this one, comes from here, and I see now I drew the arrow in the wrong direction. Whoopsie, that arrow should be going up here. Here the red carbon is accepting electrons, it's an electrophile. So this electrophilic carbon stays electrophilic throughout the entire process, as opposed to here we start out with a nucleophilic carbon that is then changed into an electrophilic carbon. So this is an example of an Ohm-Coulomb reaction, because normally carbonyls exist as carbocations, and here we're using that carbon as a carbanion. Okay, so therefore this is an Ohm-Coulomb. So we can cross out A, B, and C. D is the one where it starts out as an electrophilic carbonyl and stays an electrophilic carbonyl throughout the entire process.